So 134 is a continuation of problem 123 from 641. So I've written down the velocity equation that we looked at in that section for Stephen charting his velocity on his walk to school. And so we answered these questions yesterday, so let's talk about them again. Using Stephen's velocity equation, find a function s of t representing his distance from home. So if this is his velocity, we would integrate to find his distance equation. So the integral of velocity is, and they ask us to call it s of t, or we might call it d of t, is negative 150 times t to the fifth divided by 5, so that's going to get us negative 1 over 250. This is just power rule, add 1 and divide, plus 1/4 t to the fourth minus 31/4, 31/6 t cubed plus 75 halves t squared. Now, we could put the plus c on there, but we do know that his constant, that he started at home. So his initial distance is going to be 0, would be our constant. So we've got our integration. We've got our distance equation. Now, B says, according to this function, how far from school does Stephen live? Oh, and then if we were to graph this, it should match up with our graph given at the right, 1,000 feet-ish, and then minutes down here. I think his walk was 25 minutes. So how far does Stephen live? If it was a 25-minute walk, we would just do s of 25. Now, yesterday, you used the same velocity equation. You graphed that and found the area under the curve for his distance. Today, when we integrated, we're just using his actual distance function, putting 25 in, and we should get the exact same answer, 1,302.083 feet. We get that by putting in the 25 into his distance equation. Then it says, determine his average velocity. If he went 1,302 feet in 25 minutes, we can get feet per minute by dividing. So his average velocity was 52.083 feet per minute. Now, I love this discussion. Looking at his distance graph, s of t up here, could you graph if Stephen had gone this velocity for the whole trip? What would it look like? It should start at 0, same as that one. Should end 25 minutes later at 1,302 feet. But if he travels his average velocity, it would look just like that. Constant velocity, constant slope, a line. Now, how many times during his trip was Stephen actually traveling the average velocity? Common mistake would be to just look at the graph and say, oh, it's where they intersect. Maybe it's there, maybe it's there, maybe it's there. Now, this is his distance graph. These are both distance graphs. So you wouldn't look to see where distance graphs intersect. Algebraically, we could set his velocity equal to 52.083 and solve. But we can understand what this means in our yellow equation up here. That's its slope. So we would look for when does the slope of the other graph match the slope of our average graph. So it's going to be somewhere where the slopes are the same. And then if we were to go down here and actually solve this guy algebraically, we should get the time was 0.828 minutes. And I think it was 24.1 minutes would be the actual times when his average velocity matched his actual velocity, when the slope of his distance graph matched his average velocity. Gave you some big hints to try to answer E with words, and then we'll get together.